Hello and welcome to our broadcast, Secure Redis Deployments for Simplified Compliance with PCI, HIPAA, GDPR, FISMA, and more with Redis Enterprise. It is my pleasure to introduce today's presenter, Shihan, Vice President of Product Management at Redis Labs. With the increasing number of security breaches, it is critical to protect your data in Redis. Redis Labs provides the Redis Enterprise platform that is fully compatible with Redis open source and provides added security for Redis applications with authentication and authorization controls, encryption for data in motion and data at rest, logging, and event tracking for forensic. During this broadcast, Shihan will cover how Redis Enterprise delivers secure Redis deployments and simplifies compliance with self-imposed or industry-standard security compliance needs. Today's broadcast is being recorded. Following today's event, an email with a link to the recording will be sent to you for sharing with your fellow workmates. There is a question and answer feature in the control panel to post questions. Questions will be answered in the order that they are received. And at the end of the broadcast, we will be raffling off 2 $100 Amazon gift cards. To be eligible, you must be present to win. If your name is called, please post a note in the question and answer control panel. Again, thank you for joining us today, and at this time, I'll turn the broadcast over to Shihan. Shihan, take it away.
Thanks, Sharon. Hi, everybody. Thanks for joining in. I'm going to cover securing Redis deployments with Redis Enterprise today. So let's take a quick peek at what I'm going to walk through. For those of you who are new to Redis and Redis Enterprise, I just want to give you a quick intro and an overview of these products and give you a sneak peek of the Redis Enterprise architecture. That will set the backdrop for some of the things we want to talk about around security. It will help put them in context. We'll quickly jump into complying with regulatory requirements. I just want to cover that in a couple of different sections. So first, I want to talk about security best practices and deployment model and what we expect as a database around the product as a security perimeter. So we'll talk about defense in depth and how Redis is typically deployed and Redis Enterprise is typically deployed. I want to cover the basic security controls and Redis Enterprise. We'll go through authorization, authentication, forensics and logging and encryption in detail. I want to head on finally on the compliance requirements that are common across many of these compliance requirements in the healthcare industry or in the government or in the financial services industry, and talk a little bit about how each control addresses the specific concerns commonly across these requirements. Finally, I'll actually quickly touch on Meltdown Inspector. It wouldn't be a complete to finish the webcast without really saying a few words on what the impact of that has been and what we have done with Redis and Redis Enterprise on these. And there's plenty of time for Q&A, so please do send your questions throughout the talk. I'll try to get to them towards the end, and we'll kind of quickly recap and do the raffle at the end. All right, let's jump right in. So for those of you who are not familiar, Redis is an in-memory database platform known for its high performance in both operational, analytical, and hybrid use cases. As Redis Labs, we provide Redis open source as well as a commercial platform called Redis Enterprise that's built for enterprise mission-critical deployments. It is provided as a platform called Redis Enterprise, which we deliver to you as either software that you can download and deploy on your private cloud or on premises, or we provide the same technology as a database as a service platform on major public clouds as a managed service. I just want to quickly touch on why Redis is such a popular database I'm going to highlight these three areas for you. First of all, Redis is known for its performance. It's low latency, typically a sub-millisecond latency times at high throughputs, and its consistency of delivering the low latency even at high throughputs is something that attracts a lot of developers to our platform. Redis also is known for its simplicity. Now, the data model that underlies Redis and the way in which you express your concern, your data concern into the Redis database is very different than other systems that are available to you. Many of the other systems that are out there in terms of databases either use tables as an underlying approach for you to express your problem to the database, or maybe documents. But Redis provides a much richer data structure approach. What Redis does is essentially give you purpose-built data structures that serve the purpose with the most efficient and effective way of delivering and encapsulating the data with specific data structures, as well as verbs that hang off of them. The verbs themselves operate on things like sets or sorted sets that allow you to manipulate each one of these structures independently within the database. You can also combine a single database with many of these structures all at once. So it gives you full flexibility for expressing your problem with the best structure that is suited for that problem. If you want to use things like tables, there's hash tables that are available. If you want to use things like JSON, there's structures that will help you do that. But if you're looking for a bitmap, a list, a hyperlog, log, or a set, there are specific purpose-built effective data types there. And finally, even though Redis has quite a few built-in data structures, it also comes with extensibility for anybody to extend Redis's data type system or the command system. Redis modules provide a native way of extending Redis's capabilities. We use it in Redis Enterprise platform quite a bit to add new capabilities, new data types and new commands to the product. But anybody can do it, and with Redis Enterprise or Redis, you can actually upload your modules and have a first-class experience to extend Redis's built-in operations. The one thing that's important about Redis modules is that it's not an abstraction where Redis kind of translates your requirements, extensibility requirement, into some well-understood internal structure. You're actually getting a way with modules to directly embed your extensions at the heart of the product. And that means that they can be high performance and high throughput and take advantage of all the things that Redis provides as you do these extensibility modules. Now, Redis Enterprise adds a few important capabilities on top of Redis open source. I'll just go through that quickly. With the Redis Enterprise platform, we first enhanced the high availability capabilities of Redis open source. We provide additional high availability, durability, and disaster recovery options. We provide active deployment capabilities if you have geo-distributed applications, if you want to stretch your application across continents and have active writes to the same keys, and have a smart conflict resolution combined with that. We provide a geo-distribution, a multi-master replication technique built around CRDTs. CRDTs stand for conflict-free replicated data types, and ensure that your concurrent writes have smart conflict resolution as they happen, or simply if you're building a geo failover capability to allow yourself to be able to fail over to East Coast or the West Coast, depending on the network conditions, you can do that simply and safely with the geo distribution capability in Redis. We are going to be focusing on this area quite a bit today, but there's also a ton of security controls that we provide on top of Redis open source with Redis Enterprise. We also provide a great deal of performance improvement on top of Redis open source. This comes in the form of the ability to scale the product. So applications can have a smooth experience as you turn the dial up to gain more computational capacity in your databases. So the performance at scale of Redis Enterprise is built to handle very demanding workloads. We also provide high performance query and search capabilities on top of Redis using the modules modules technique that we talked about in the previous slide. But we validate these and test them and provide these added functionalities within Redis Enterprise. Redis Enterprise also comes with great cost savings. It provides automation for your placement of the databases. It comes with multi-tenancy support, where you can densely populate a single node with hundreds of tenants if you wanted to, or hundreds of databases in a single cluster. We also provide enhanced storage and memory management capabilities. Redis Flash is an example of that. With Redis Flash, you're not only confined to running your Redis database purely in RAM, you can also push part of your data to flash storage like SSDs, and that provides for large data sets a great cost saving, given that flash storage is about 10 to 20 times cheaper than the gigabyte of RAM that you typically get. So these are some of the things that Redis Enterprise provides. It's a mature technology. We've actually been running Redis Enterprise in the cloud for quite some time. We manage over 550,000 databases worldwide around multiple public clouds today. The database as a service capability, Redis Enterprise Cloud and Redis Enterprise Cloud Private, have over 7,500 customers today. And it has over 80,000 free customers who are enjoying the service for free as well. On the software side, you can also get Redis Enterprise as a downloadable software, and this product is more recently been available since early 2015 and has over 200 enterprise customers as well. Redis Enterprise and Redis in general is in use in many of the customers you would recognize. It's rare that we walk into a conversation with any of our customers and find that they're not running Redis. So typically, Redis is considered to be everywhere. All right, let me touch on Redis Enterprise architecture. This is going to help us as we go through the security controls. Redis Enterprise Cluster is the underlying. So the architecture that you're looking at here is the underlying architecture for both the cloud services and the on-premise product. We have a single mainline code, and we provide some small additions for each specific deployment type. Like in the cloud, we will have metering, and in on-premise capabilities, we'll provide a management UI that administrators can use. But fundamentally, the architecture is the same for both products. The Redis Enterprise Cluster node comes with a set of technologies that we install. There's the red slice of the cake that you see on each node, which is what we call the data path. This contains Redis shards, many Redis shards per node. The administrators get to control how many they'd like to put. In certain cases, if we're hosting very small tenants, there could be hundreds on each node. Or if it's a large node, we may put a large number. But the administrators have full control over how they place these shards across different nodes. Each node in the system can carry shards. The Redis shards that we use at the data path in Redis Enterprise is different than Redis open source. It's actually an enhanced version. From an application standpoint, Redis Enterprise and Redis is 100% compatible. So your applications can simply work against Redis and change their connection string, and they will continue to work against Redis Enterprise. But underneath, the Redis shards that we have in Redis Enterprise will have enhancements such as scheduling enhancements or memory management enhancements. They sometimes, depending on the type of database that you create, will come with enhanced storage or memory management capabilities, etc. So there's a number of differences there. And on the blue layer of this cake, you see the cluster management path. This is where a lot of the governance happens for the cluster. The blue layer is responsible for running the watchdogs that watch the system and the rest of the nodes in the system. It's fundamentally the governor of the cluster. It understands where the nodes are, what their states are, and how to place databases and how to enable replication, etc. within databases. There's also a proxy capability that's embedded at this blue tier of the product, which manages connectivity. So applications don't directly connect to this Redis shards. In the case of Redis Enterprise, they actually go through the proxy, and the proxy takes the connections directly from applications. There's a couple of efficiencies that come from this. One of them is that we will use pipelining techniques to take operations from multiple clients and pipeline them to the same shard if they're targeting the same subset of keys, or keys that are subsetted into the same shard. We will also enhance connection management through the proxy. So if there are many mini tenants and hundreds of app servers with tens of connections each, the proxy will ensure that there is one connection per node that comes in from the application, and you can talk to as many shards as there are on that node through the proxy. So the connection multiplexing problems, I don't know if anybody's familiar with them, but this is the industry term. The connection multiplexing problems that happen with large number of shards in client applications does not happen with Redis Enterprise. We scale the number of connections really to a much higher level through the use of the proxy. All right, so let's focus in on our topic of the day. Let's take a look at what Redis Enterprise does for simplifying compliance with regulatory requirements. Before I get into a lot of the details of what controls Redis Enterprise provides, and it provides quite a few, it's important to understand that the surrounding area also needs to be secured. The security controls are just simply not enough by themselves to secure your data. And deploying Redis in a secure, physically secure data center in a secure environment is an important part of your defense. So I just want to cover this a little bit. The typical Redis Enterprise deployment happens within a data center where there is a top-level switch. This edge firewall is there to protect anonymous, unknown traffic in the wide area network from getting into the data center. These kind of top of the data center switches are there to protect you against common attacks like denial of service, etc. They filter the traffic, and you can at least turn off some of the noisy traffic out at the edge of the data center before it actually makes it in. We also expect Redis Enterprise to be behind the perimeter network. The perimeter network is where you would expect a lot of your web servers to be in, for example, where the anonymous traffic is allowed to come in, but this area is still filled with somewhat unsecure communication. This is where some of your applications and administrators may come in from as well, but this perimeter network is still an area where we expect anonymous traffic to exist, and Redis Enterprise as a database is not really designed to be exposed into anonymous traffic, at least in kind of the deployment models where you're following best practices. And finally, we expect Redis Enterprise to have a wall around the cluster to protect the cluster's internal network. So this is kind of the innermost protection area where the communication that comes to the nodes are ensured to be communication that is going to authenticate to the database or to the administration control plane of the product. And the nodes themselves that are talking to each other among themselves will actually have kind of a high performance exchange and encryption, high performance network exchange, but the communication that comes from outside will actually go through a more stringent check. The practical implication of what I'm plotting here is really mostly IP tables and essentially kind of preventing any random communication from getting to the database servers, and allowing the nodes of the cluster to really freely talk to each other without having to go through stringent checks. So these three walls, the data center wall, the perimeter network wall, and the cluster's internal network, are really three different levels of protection that you need to pass through before you get to reach and talk to Redis Enterprise. And this ensures a defense in depth posture that allows you to then apply the Redis Enterprise controls on top of for the best kind of security. A few of the things that I want to highlight on this picture is there's obviously encryption that you can enable on all of these communications that happen. So both the administrators who are coming in from the perimeter network typically will come in from an encrypted communication channel. They're going to authenticate through a password-based mechanism. They may even integrate with an enterprise central account management system that is LDAP capable, so that those accounts will actually be authenticated by the LDAP store before they are let into administer Redis Enterprise clusters. Or the applications that reside in the perimeter network can actually come in with encrypted communications and with multiple factors like certificates and passwords, so that the communication with the database only happens if all of the secrets are presented at the time of data communication. We also provide encrypted communication within the cluster nodes through IPsec. You can set that up. Or data at rest encryption with OS level file encryption, or through partner products that will actually do much more fine-grained certificate management for you and data at rest management. Finally, just want to touch on the cross-cluster replication. There are moments where data from Redis Enterprise cluster is replicated across the WAN to other remote data centers where either other Redis Enterprise clusters exist, or this could be a source where the source is Redis open source as well. But this encrypted communication can actually be engaged in these cross-cluster communications as well, when both ends of the replication is Redis Enterprise. All right, so this really is a busy slide, but it's a good overview of what we're going to cover. I'm going to touch on many of these controls that we talked about on this slide later on in the presentation. Before I also get down directly into the controls, I want to talk about development and test cycle and the deployment of Redis Enterprise that we manage, and how we ensure security throughout the full life cycle of the software. First of all, we engage SDLC, the secure development lifecycle techniques. There's automated security and vulnerability scanners on all of our builds that do automated checks for us, and we'll do regular penetration testing, especially on the cloud services as well as the on-premise product. On the DevOps and operational side, we're also working towards and fairly close to attaining SOC 2 compliance. The SOC 2 coverage, for those of you who are not familiar, is about security, privacy, availability, and process integrity. We're in the late stages of compliance, and by mid-2018, we expect that SOC 2 compliance will be achieved with our services. So throughout the development life cycle and later on in the DevOps cycle, we're applying security controls so that the full process of developing the software and delivering that as a service is something that we do with following best practices. All right. For most of you, the next few slides are going to be fairly familiar in terms of what you expect from the product. I'm going to cover major security controls, I want to talk a little bit about how we do authentication and what controls are available for you at that moment. I'll talk about authorization controls within the system for both the admin path and the data path. We'll talk a little bit about forensics and what type of logging events we actually have in the system. I'll cover finally the encryption capabilities in the product, both for data in motion and rest. And then we'll wrap up by talking about regulatory compliance requirements and how these controls help comply with these standards at the end. So let's start with authentication. We talked about authentication as part of the product as having two different paths. The management path has a different authentication protocol for administrative accounts. The management path allows you to do things that are fairly destructive to the whole set of databases in the cluster. There are multiple tenants involved in many of the deployments, or multiple databases and multiple applications. So the admins have a wider span of power within the cluster. Thus, administration, identity management and authentication is done separately from the data access management. Administrators' identity can either be managed by a built-in set of accounts. You can create them through the UI. In the initial provisioning of the cluster, there's a super admin that you create, and that admin account is then used to create other administrative accounts. You can either use the built-in capabilities to manage the administrative accounts, or you can use an identity management system through LDAP that is central in your organization. So a single password or single password complexity or expiration policy is applied to all of these accounts. If you want to do that, it's fairly easy to connect the product into LDAP, and what we'll do is that the accounts that come through to authenticate will actually be checked and delegated, essentially, if they're LDAP accounts, delegated to the LDAP store, and the LDAP store is going to authenticate them into the product. The identity management for applications is done separately. That identity is the identity of the applications, and that access is restricted to data access in the database itself. It's each database in the system gets can get a secure password, and can also enable certificate-based authentication as well at the same time. So the applications may need to present both a certificate and a password at the same time before they can actually connect in to access data. If one of those secrets are missing, if the password is wrong or if the certificate does not match, we will deny the connection of the application. You can also do IP whitelisting for data access. This is easier and simple to do in the cloud products, or within the on-premise deployments. IP tables will enable simply to help you do this. When it comes to authorization, for admins, we provide role-based access control. So there are two fundamental distinctions at the top. There's cluster administrators and database administrators. And both of these roles will also have either a full edit or a view-only access to the product. So these are the built-in roles that we provide, and you can assign each one of the administrative accounts, either that are coming through LDAP or from the built-in store, to be able to do only a subset of the operations, such as administering databases. So in those cases, for example, a database administrator cannot add or remove nodes from a cluster, so you can restrict their access to the cluster. On the authorization side, there's also tenant isolation. So each on the data access path, each tenant or each database is analogous to a security control containment. Each database contains a set of data that is protected. What I mean by that is each database contains data that's protected by the password and the certificate that's enabled on that database. And each tenant can have an independent password and an independent certificate to isolate its data from other tenants the system. The system also provides tenant placement controls that are really fine-grained. So if you want specific tenants to not share common nodes within the cluster, if you want to isolate tenant 1 from tenant 2, then you can do those things. And we actually have some of these controls applied in our database as a service product. So there are free tier of our products and different levels that you can purchase. And depending on the quality of the level that you've purchased, you may actually get all the way up to a dedicated cluster that does not have any other tenant on it, et cetera. So there's a lot of tenant placement strategies that can be engaged to create isolation between these tenants. Let's take a look at forensics and logging. Well, it's important to be able to track all the things that are happening on the cluster and be able to go back in time and understand what happened that led up to a specific event. So admin action logging is an important part of this. We essentially have a centralized log that will report on general events, such as adding or removing nodes or databases, or licensing changes that impact the cluster. We also have specific logs on each one of the nodes that will report on issues and detailed events happening within a given node. And all of these, the centralized logging is integrated and central, so you have a single view from the UI or from the REST API that you can get all of this information, or you can go to each one of the nodes and individually take a look at their logs. This system is integrated into the standard RSys log approach in the Linux environments. We track events such as authentication errors, database creation, import, export, or delete, so major data and database changes. We look at node level operations, so any adding, removing, or offlining of nodes, upgrades, or addition of users, changes to the security control plane. Addition of users, removing of users, or updating of users are things that are tracked. There's a list of these operations that we provide as part of the product, and you can find this in the package that you download. And these are some of the events we track today, and we continue to add more to the list of events here. There's also monitoring and alerting that we provide that is built in to the product. There's essentially, these are interesting from a security standpoint as anomaly detection techniques or runaway operations, but you can alert on running low on disk space or heavy usage of a specific database, et cetera. And alerts are both at the level of the cluster, so you can get alerts at the cluster level events, or at the database level, where each database administrator can enable a specific subset of the events for each database. And these are ways in which you can track events. We make a much larger set of stats available, both for troubleshooting, monitoring, and alerting through the REST API. So any tool that you have standard in your enterprise that can speak REST can connect and directly munch over this data as well. Okay, finally, I just want to touch on encryption. Encryption, I'll kind of cover data at rest and data in motion here as part of the slide. But when it comes to administrative access, we provide an HTTPS endpoint, a REST API, and a UI that goes through HTTPS that will encrypt all the traffic back and forth. So administrators, even if they are coming from the internet and not through some perimeter network or a jump box, they will actually have an encrypted communication directly with the cluster. You can also enable encrypted communication for data access. In this case, client applications will provide a certificate and encrypt the communication between the server and the client using the certificate. The certificate-based authentication and encryption essentially will encrypt all the phases of connectivities from the initial authentication all the way to regular data access afterwards once the connection is established. So this encrypted data access is there. We also provide for WAN-based replication capabilities within the product, encrypted communication across the WAN. We provide two, just to kind of double click on this, we provide two main ways of replicating across clusters. One is the active-active deployment that we talked about in the introduction section. This is the conflict-free replicated data types, or Redis CRDTs, where you can actually have both clusters actively writing to the same subset of the data. In this mode, we create a global database that spans multiple clusters, and the communication between these participating clusters in this global database will actually happen in a replicated fashion. We're about to complete this capability. This is going to be available very soon, and will be coming in the next few weeks as part of 5.01 version of the product. We also provide Replica as a capability, which fundamentally is for active-passive deployments. If you're looking for a CDN-like distribution of your data to multiple geographies, it has the ability to have cascading replication topologies, etc. And in the case of Replica, you can also enable SSL-based communication and run WAN-based replication that is available today. Before I leave this slide, I'll touch on data at rest encryption as well. That's done through file system encryption. The product is practically agnostic, but you can go and encrypt the specific locations that we store our files in, either for the persistent data or for the ephemeral or the flash data that we provide. You can also use third-party products such as Protegrity or Zetaset, etc., and have much richer certificate management if you'd like to do that. So we've got third-party integrations like that that enable much finer grain control over encryption of data at rest. All right, it wouldn't be complete to go through this webcast and not talk about Meltdown Inspector. These are the recent alerts that came out with some of the chip architectures out there. So we put out a couple of responses, but if you haven't read the specifics on, I just want to give you a quick summary and then point you back at the specific details of the analysis so that you can go read the full details here. For Meltdown Inspector, we've worked with cloud vendors to patch our environment, so that patching has completed. On the on-premise products, the operating system vendors have provided the PKTI packages and patches, and these are continuing to evolve. I think there's additional patches and updates that are coming from each one of the vendors, but we obviously recommend that you install these things and or use our cloud service so that you don't have to worry about patching your systems yourself. With Meltdown Inspector, there was a large conversation around the performance impact of what the patches are doing, and we confirmed that there is performance impact. On our cloud services, we've actually done quite a few measurements to understand what the impact is, and watched the before and after pictures of the patches application and the customer traffic. For Redis Cloud Private deployments, we see about 2.5 to 5% impact. It's actually fairly limited and small. The context switches are one of the reasons why it doesn't impact Redis Cloud Private as much. That there are fewer context switches in Redis Cloud Private, and it's designed for larger data sets. With the Redis Cloud with multiple tenants and essentially an environment where you have kind of a fully managed experience, but are sharing the infrastructure with other tenants, we see about 5 to 30% impact. So this could come at both the latency and the throughput of that you experience with our services. The range of the impact really depends on the type of operations you're running and the data set that you're engaging in, et cetera, in your database. There's detailed benchmarks. If you want to read more about the results of our tests, you can visit our blog at redislabs.com/blog. It's one of the ones at the top, but look for Securing Redis Enterprise for Meltdown and Inspector vulnerabilities. If you search for that, you'll find our detailed blog on these topics. All right, so we've talked a lot about compliance. We'll talk a lot about controls, security controls for administrators and data access within Redis Enterprise, but we really haven't detailed yet how all of these things fundamentally help you comply with regulatory requirements. When you look at many of these regulatory requirements, PCI, HIPAA, FISMA, GDPR, there are specific operational requirements that need to be validated for you to be able to comply with these standards. But the database can definitely simplify and help you get there. And each one of the security controls that we've talked about, from authentication to authorization to forensics and encryption, really provide a set of controls that let you simplify the process of complying with these standards. And our SOC 2 compliance and our SDLC practices hopefully also validate and verify that you're running a product that's built for the enterprise. So let's, what I did at this table is really summarize a set of compliance requirements that are commonly referred to within the external regulations like HIPAA, GDPR, PCI, and others. And I've, on the right side of this table, referred to the specific controls that will help you comply with the requirement. So in many of the compliance requirements, you will find that development and test lifecycle or development lifecycle controls that need to be in place. We talked about them as SOC 2 compliance, which is coming soon, or the SDLC that we follow in development of Redis Enterprise product and testing of the Redis Enterprise product, the automated vulnerability scanners and security scanners that we use. So these are things that we provide to help assure that the development life cycles for this product goes through rigorous check. On the firewall protection for sensitive data, which is a common requirement that comes across in HIPAA or PCI, we provide IP filtering help. This is more automated in the cloud. You can actually just simply put the IP addresses of the application servers that you want to allow to connect to a specific database. In the on-premise product, you can do this at a fine-grained level with IP tables controls, but these are available for you to control which nodes, which IP addresses, which source IP addresses get to talk to a specific subset of your data. Password complexity and expiration policies, this come up quite a bit in many of the requirements as well. The LTAB integration is the way to go when requirements require specific complexity and expiration policies to be applied to accounts. The LDAP stores that you use centrally in your enterprise do comply with these, and the LTAB integrated account management means that we will delegate the account authentication to LDAP, and the password, etc. is the metadata about that account is not really stored inside Redis Enterprise, except some small portion to identify that account as an account that we need to delegate to LDAP authentication. Encryption of data in motion. This is where all the encryption capabilities we talked about come into play, both for the administrative accounts as well as for the data access path. We also provide inter-cluster communication encryption through IPsec. This can be enabled fairly easily. If you want to walk through this process of enabling IPsec, we recommend that you talk to support and go through our support services to do that. For encryption of data at rest, which comes up again quite a few times in HIPAA, GDPR, PCI, etc., we provide disk-based encryption with the product. So if you encrypt your file system, the product will simply transparently continue to work and encrypt the data that we save to disk. Malware vulnerability protection. Again, our automated code scanners during every build ensure that the common issues that we see, that are well-known type of attacks, are protected against. We use a couple of different tools to go and scan our code in an automated fashion. And the penetration testing is also another way in which we surface some of these issues early on in the development process. We also encourage anybody who wants to report issues that they find to call support and directly talk to our team here to report the concerns and issues that they see. And we use the standard severity identification methods to identify the attack potential and the severity of the issue and respond accordingly through the support process, through our 24/7 support. Restricted access to sensitive data. Again, role-based access control for admins is one way in which we actually provide this. Data access also gets isolation through each database with their own password and certificate that needs to be presented for databases. Authentication of access to data, again, LDAP and two-factor authentication with X509 certificates. These are ways in which we provide security. And finally, vulnerability response plan. We actually work with our support organization, 24/7 support organization, to listen to reports and understand security issues and vulnerabilities that come in through our customers or through the reports, and we triage and identify these issues with the right severity and resolve them quickly, as quickly as we can, depending on the severity, and come back with product updates, patches, and so on. This happens automatically in the cloud, and for on-premise products, we notify our customers about these issues as they come up. These were some of the examples. So let me just quickly recap. We looked at Redis and Redis Enterprise, quick overview and architecture. We talked about what Redis Enterprise does to secure its deployment in the cloud between the data center and the perimeter networks and the cluster intra-communication controls and deployment best practices. We looked at security controls in Redis Enterprise, starting with authentication or authorization. We looked at logging and forensics and encryption capabilities in the product, touched on Spectre and Meltdown, and finally talked about some of the common requirements in many of the compliance requirements and how each one of these controls apply to them. This is pretty much all I had. I'm going to switch into Q&A and see if there are any questions from the audience. Let me read a few of these questions here. I think the first question is not necessarily all that related to security, so I may actually skip over this. It's speaking about dictionaries and sorted dictionaries and how to implement them. I'm actually going to reach back out to you after the call and over email, and we can, if your email was in the list, and send you some documentation about these things. The second question that came up is the encryption for data access supported both in Java and C# libraries? The answer is yes. There's a couple of different libraries for Java and C#, and there are alternatives out there that provide encryption, simplified encryption for the client libraries to present the certificates that are required to encrypt communication to the database. So it's fairly simple to do, and there are good how-tos on the website if you'd like to do an SSL-based communication with Java or C# or Python or any of the other languages that you have. Another question I see is, can one use self-signed certificates for data access encryption? Yeah, I missed touching on this, but yes, you can certainly use self-signed certificates as well as CA-signed certificates for data access and for the admin access as well. In both of these cases, the certificate is fundamentally what we'll use to encrypt the data. So we don't necessarily care too much within the product about the signage per se. One thing I want to note here is that some of the certificate capabilities like expiration are not rigorously checked. So we depend on the admins to do additional checks for certificates. There's capabilities to allow you to rotate different certificates into the system if you want to change your certificates during flight. One other question I see here is how do we report any future security issues? I touched on this at the very end, but you can contact support at any time. You don't have to be a paying customer to call support. We have free tiers of our product. You can either do that through email or the web system or through the phone, but you can come in and report any issues, and we'll respond accordingly to depending on the severity of the issue, etc. And if it's been fixed in a version of the product, we'll let you know that there's a version of the product that you can use to fix the exploit. Let me read one more question here. What's the architecture of your RBAC components? So the built-in roles that we have within the product essentially are fundamentally controlled by the product. We don't provide yet a role-based access control that's user-defined. So the ability to integrate into third-party platforms for permission control is not there. These built-in roles are things that we're continuing to enhance, and user-defined roles are something that we will add to the product in future. They're not there today. So these are fairly static roles that divide up essentially a read-write and a read-only access, both for cluster administration and database administration today. And on the forensics and logging side, I see a question about, are your logs immutable? The log protection is essentially something that you can do yourself. I can't say that they are completely immutable, but our recommendation is through the RSysLog techniques that you move the logs off the machines and feed them to another secure area where you can secure these logs. So fundamentally, there are ways to tamper once an operation is done with the existing logs. If you have the right privileges and permissions, if you're an administrator, for example, it's very hard to stop you from tampering with some of these audit logs. But generally, with the separation of roles, if you're a cluster administrator or a database administrator, you don't have to have specific permissions directly to these files, and the system is set up in a way that does not allow you to have access to them. So I want to just recap. There are ways in which you can elevate the privileges where you can tamper with these logs, but the deployment structure is such that, for example, in our cloud, that our administrators, our DevOps, does not have access to these logs, and you can set up Redis Enterprise yourself on-premise deployments with the same kind of security model. So the tampering of the audit logs is minimized or impossible. and the permissions that you provide to regular administrators do not allow them to do that on the machines. If you get an alert, can we quarantine actions? Not sure I understand 100% what you mean by quarantine, but if you get alerts, you definitely can have ability to turn off data access or ability to freeze accounts in the system, so those actions cannot be performed. These are things that you can certainly do. If you're looking for something more enhanced than that, as the quarantine, I'll reach back out to you through email, and maybe we can discuss that over email if you're looking for something more sophisticated than that. But there are definitely controls within the system for you to be able to either take out accounts or downgrade privileges or prevent data access, etc., from a specific type of application. So these controls are there in the system, and you can do them, but they do depend on operational excellence as well at the same time. So you do need to set them up up front. All right, I think we covered most of the questions. If there's nothing else, I'm going to quickly recap. So you can download our products, the software products, and deploy it on Mac OS, Windows, or Linux-based operating systems, or using Docker, Kubernetes, or Pivotal Cloud Foundry. You can also sign up for our cloud services. We're available on major public clouds that are available out there. So I encourage everyone to do that. With that, I'm going to pass it on to Sharon to go through the RedisConf and raffle pieces.
Hey, Shion, thanks. Well done, another full house. So sign up for RedisConf 18, taking place on April 24th through the 26th in San Francisco. We have 2 training tracks on day 0, which is April 24, and 5 session tracks taking place on the 25th and 26th. You can register today for the early bird registration fee at redisconf.com. Okay. So here we go. Now it's time to give a shout out to 2 of our raffle winners of the $100 Amazon gift cards. So here we go. Our first winner is, one moment, Prakash Sivagnanam. Again, that's Prakash Sivagnanam. And our second winner is James McRogan. James McRogan. Prakash and James, hey, congratulations. Ping us on the Q&A panel and provide us with your mobile numbers, and we will contact you shortly. So we're at the end of another broadcast, and on behalf of the entire Redis Labs team, thank you for joining us. An email will be sent with a link to the recording of today's broadcast. Check out our future broadcasts at redislabs.com/webinars and register today. So until next time.